Hello, everyone. Good morning, afternoon, or evening. Dear authors and invited guests, welcome to Technical Session 10B. My name is Alesha Mulla, and this session will be moderated by me. On behalf of Global Knowledge Research Foundation and GR Scholastic, it is my great pleasure to welcome you to the 11th International Conference on Information and Communication Technology for Sustainable Development, ICT4SD 2026 in Goa, India. The 11th edition of the conference is being organized in a hybrid mode. The physical event was held on the 9th in Goa, and the virtual event is being held from 9th to 11th July 2026 via Zoom. I hope you will enjoy the knowledgeable and interactive sessions throughout the day. In this session, we will have 10 presentations. Each presenter will be given 10 minutes for presentations and 2 minutes for question and answer. On the 9-minute mark, I will raise a gentle reminder. There is another request to all the participants. Please stay connected with us till the closing remarks. If you have any query or update, then you can write it to me in the chat box. Before we start the session, I would like to introduce you all to the chair for today's session. Dr. Parvinder Singh is a proctor, nodal officer, AICTE Doctoral Fellowship Scheme and professor in the Department of Computer Science and Engineering at Deenbandhu Chotu Ram University of Science and Technology, Murthal, India. Bringing over 17 years of distinguished experience, his research interests primarily focus on information security and data hiding, and his scholarly contributions are widely recognized through numerous publications. Welcome, sir. I request you to please say a few words. All right, we'll move on with the first presentation. Our first presenter for today is Jainam Shah, who will be presenting a comparative study of single LLM and mixture of agent approaches in model context protocol based tool using systems. You may now begin your presentation.
Good morning, all. So, the research paper we are presenting is a comparative study between a single LLM and a mixture of agents. So we have seen that whenever we used to give a prompt to a single LLM, it's more efficient in giving the output. But
Excuse me,
it
Jainam. I'm so sorry to interrupt. Could you please share your screen?
uh, I'm not able to share my screen. We'll try to division feature, if you can share your screen, if you are able to share your screen, can you please, if possible?
If there's any issues, we can circle back to you later on and we could continue with the next presentation.
Yeah, sure.
All right, just a moment. We'll now continue with the second presenter for today. Our next presenter is Bansari Manwal, who will be presenting a literature review on multilingual large language models for low resource language processing. You may now begin.
Hello. Hello.
Yes, you're audible.
Very good morning. My name is Bansu Manwar. And
Excuse me, I request you to please speak a little louder. We can't hear you very well.
oh, now I am audible.
Yes, you are.
I hope my screen is visible.
Yes, it is.
Very good morning, all. My name is Bansri Manwar. I am a PhD scholar from iStar College, CBM University, Anand, Gujarat. And my today's presentation topic is a literature review on a multilingual large language model for a low resource language processing. My go through of this presentation is first I am presenting abstract, then introductions, literature review, methodology, gap area, problems, proposed techno-ethical
Miss
process.
Bansuri, you are not audible.
Hello.
Hello, Miss Bansuri, you are not audible.
Just a second, sir. Can I audible, sir?
Just a little bit.
Now,
Better than before.
can I start my presentation in this?
Yes, please. Yes, please.
Okay. So, first I started my topic is a literature review on a multi-language large language model for a low resource language processing. My flow of a presentation is first discussing the abstract, then introduction of my paper, then a literature review. After that, I methodology what literature reviews paper are followed, and then I write a gap areas. After that, a problem statement I define, and then how proposed a techno-ethical process then work, and objective and contribution of this paper, then technical background and a future direction. After that, I conclude my presentations. Now, second is starting with the abstraction. Large language model have a significant advanced natural language processing. This now you can see this paper present a consensus literature driven study and propose a techno-ethical framework for inclusive low resource NLP. So first I have to define just a third point and this figure multi-language transfer model. I have to first we have to gain knowledge from a high resource language impact and low resource language. Second, cross language understanding model, learn for understand and a meaning of a act. So third, COPS in infrastructure, organized data set and tools for storing. Then last, fourth, participatory AI. So community when involved in collecting and validating a language data. After data collecting, again a multi-transfer we have to connect that data in a multi-language transfer model. So the proposed framework integrate a transfer learning with a participatory curves, creations and a bias-aware evaluation to enable equitable language technology. If I have introduced this paper, so transfer-based language models such as a BERT enable a high accuracy transfer summarization and a question answering model. So despite this progress, most AI systems support a fewer than 100 language overall of worldwide languages. There is a 7,000 more than a 7,000 languages are there. Low resource therefore represent both computational and a societal challenge. Recently, research demonstrate the transfer learning and a multi-language. Sorry, 1 second. However, ethical study argue that technological inclusive without community participate is risk data exploratory. So next, if I've said the literature review, I divide my literature review in three sections. First section is a community and a low resource language foundations. Second is a multi-language model and a transfer learning. Third is a evaluation benchmark and a participatory performance. So I will go, if I read the section 1. So this 4 paper from respected indexing status, tribal language in a digital perspective, Dolly advanced NLU for a low resource language. And this methodology consists of linguistic digital documentations. And the limitations of these four all paper is some, if I am summarized, so machine learning or automation survive only experiments. Conceptual study, no implementation in the model. So limited dialectic diversity are there. Second section is a multilingual model and a transfer learning. This sections consist transfer learning models like transfer learning for a low resource NLP, multi-language pretending scaling, cross language representation, and BERT. So this methodology consists of transfer learning models only tested on a classifications data, resource heavy data they have to adapt. And third is evaluation benchmark and practical performance. These two paper are I have divided in this sections, and this section large multi-language evaluation benchmark are adapt like as SBI 2000 topic classification and a Florida 101 data set. And that limitation is only topic classification and limited delicate inclusions are there. If I am summarize my literature review, so first, technical study focus on a performance, linguistic study focus on a preservations, and ethical study focus on a ownership. But no one study integrate all three. If I said, okay, like this summarize technical performance focus study. So accuracy, scalability, cross language transform or proficiency. This methodology consists like accuracy F1 score, BLU score, and cross language transfer accuracy, which are widely used in a multi-language benchmark evaluations. Now I consist as language conversation focused is documentation and a designation and a conservation of an environment indigenous languages rather than on a predictive optimization. So I find some equations. Language conversation is defined as a LC. So ND is a number of a digital document linguistic unit, and NT total linguistic resources available in the community. If I am study and calculate that to this study attempt to maximize linguistic representation by algorithm performance max in LC, linguistic coverage LC. Ethical and ownership centered study methodology decide the language ownership. They are highlight a language ownership only, data authority and community participating. If I have authorized, if I have ethical study is described to CPI divide by CT. This is CP is a data set with a community participation and a total data set used. The high ethical presence indicate a stronger community-based AI growth follows, which are dependable with involvement of NLP creativities. This is my research gap. The technical performance is currently attention is a very high, but gap is a need a low resource optimizations. Second is a linguistic preservations. Currently attention is a very moderate and a limited integration into AI model. Ethical inclusion is currently attention is a very low, but lack of a community participations. The computational efficiency is improving, need wider adoptions. Low resource quietly struggle in operational challenges. Some following reasons are there. So limited training data, limited computational resources, lack of ethical and a community-based data set, and discrimination in evaluation benchmark.
Excuse me, I'm sorry to interrupt. You have 1 minute left.
Okay. This is the program area. 100 languages are there. Like data set representation, digital, cultural, inclusive, ethical, and data ownerships, and higher competition reputations. And this is the proposed ethical model. First, we have to identify my research, and then technical study, define, then language study through the preservations, then ethical study, and then proposed model. We have to create. And this is the objective and a contribution. Develop an inclusive NLP framework and a performance ethical presentation. Contribution is a unified techno-ethical NLP life cycle and sustainable through a community feedback. This is the transfer learning, low resource NLP, knowledge transfer from a high resource to low resource, this defined multi-language, embed like a fine tuning. And this is the challenging impact in a future direction to data security, cultural bias, and high competitive costs. It's a challenge, but impact is a poor model accuracy and unreadance and a feedback in. So I conclude that a low resource NLP is not only a technical problem but also a social and a linguistic inclusion challenges. Community participation and ethical data governance are essential for trust and a sustainability. Therefore, the future of NLP restrict communities rather than replace them. These all are my references what I used. Thank you very much.
Dr. Singh, if you have any questions, you may ask.
Yes, Miss Bansuri, how many paper you have studied for this literature?
Mainly I am listed 30 papers, but I am bifurcate in a 10 paper for my this literature review. I am showing in my slide. If I show again,
I think you have shown 13 papers in the slides.
yes, for the writing a paper, I am using that reference of different paper, but I am study only 10 paper for my particular subject, and I divided that review paper in a 3 different section.
Okay, as you have told, the recent systems are working on around 100 languages, means the models are considering 100 languages. So,
Yes.
how many languages will you consider in your model? Will
How
you
many?
enhance the number? Will you enhance the number of languages?
No, sir. It's an approximate number.
That you are using the already existing models and you will collaborate two models or you will propose a new
I
model.
want to collaborate. Yes, I am proposed this 3 different thing like a community and low resource language foundations, multi-language model transfer learning benchmark. If I connect this 3 study, I integrate all the I think multi-language model for a low resource. There's accuracy is some more accurate.
Kindly come to the slide
This is I proposed, sir,
where
in
you
my
have
paper.
shown the research gaps.
Yes, sir. This is a research gap.
So needs low resource optimization. What it means?
Sir, in a technical study, like a Ambert, technical performance accuracy is very high. But in terms of a low resource, they need optimization for that. That models are still not accurate for that.
Okay. Thank you very much. Thank you.
Thank you, sir.
Thank you. Our next presentation for today
Thank you.
will be by Sheikh Janbhasha, who will be presenting a quantum-enhanced spatiotemporal deep learning model to automatically classify arrhythmia on the ECG. You may now begin.
Smita, good morning, madam. This is Sheikh Jan Basha. Going through my share. Yes, ma'am. Morning to everyone. Yes, sir. Am I audible, madam? Hello?
Yes, you are.
Good morning. So this is Dr. Sheikh Jan Basha from CR College of Engineering, Hyderabad. So my paper title is a quantum enhanced spatio-temporal deep learning model to automatically classify arrhythmia on ECG signals. Here my paper ID is 514. So this is the today's presentation agenda, the abstract, introduction part, the literature survey, proposed methodology, result and analysis, conclusion and references. So this is about the abstract. Here, as you know, after COVID, most of the people they are affecting the cardiovascular problem as well as the Alzheimer disease. And according to the WHO survey, yearly 17 million people are passed away due to the arrhythmia problem, due to the heart cardiovascular problems. So that's why early detection of the cardiac arrhythmia using ECG signals is essential for reducing the cardiovascular morbidity and the mortality. So here, many methods are proposed, but so we also proposed a new method. So here we use a quantum enhanced spatiotemporal deep learning framework, so which will combine the combination of 1D CNN, transformer encoder, and the variational quantum circuit for automated ECG arrhythmia classification. So this one integrates all these 1D CNN, transformer, and the variational quantum circuit. So here in this experiment, we have used the MIT DH arrhythmia database. And here we achieved 92.8% of accuracy and precision 91.6% and 92% recall and 91.8% on score. So the proposed framework outperforms conventional methods such as SVM, CNN, and CNN plus STM, LSTM, and CNN plus transformer models. So this is the introduction part. The cardiovascular diseases are a leading cause of global mortality. So as we know, every time people are suffering with cardiovascular diseases, most of the people are lost due to this cardiovascular problem. So to detect the cardiac arrhythmias automatically, conventional ECG interpretation is using. This is a time-consuming and requires expert cardiologists, creating a need for reliable automated arrhythmia classification system. So coming to the existing, most of the existing deep learning models are used to detect the cardiac arrhythmias automatically. So among them, CNN, LSTM, and transformers are effectively extract the future and extract the spatial and the temporal features. But how they have limited capacity in modeling complex nonlinear future relationships. So this framework proposes a quantum enhanced spatio-temporal framework. So that integrates all these CNN transformer and variational quantum circuit. So this is the literature survey based on my topic. So we have collected a number of literature surveys. Among a few, I have going to present here. Among the support vector machine. So here, which is also used to extract the handicraft, the ECG filters. But they are limiting their capability to capture the complex patterns. So here the accuracy is 79%. Coming to the conventional neural network, CNN. So CNN is one of the best method for ECG arrhythmia classification. So which will automatically extract the local ECG morphological features and which has achieved 85% of accuracy. And some of the hybrid models, the CNN and the LSTM, so both will be used for spatial future extraction and the temporal sequence learning. So their improved classification accuracy up to 88%. Now coming to the CNN and transformer filters, so they will integrate CNN for a local feature extraction and a transformer for self-attention for global temporal dependencies. So they achieved more than 90%. So here, some of the limitations, because of these limitations, so we propose the quantum enhanced spatio-temporal framework. So here we achieved more than the existing methods, performance, metric, accuracy, precision, recall, and analysis. This is the proposed methodology. So in this proposed methodology, so ECG signals are selected from MIT DH dataset. So they are pre-processed So with the help of whenever the preprocessor, so whatever the noise is there of any duplication or any repeated values are there, so they will be removed and segment normalization segmentation will be done. So coming to the once the pre-processing is done, the AC signals so they are given to the 1D CNN. So here we are going to extract the spatial features, and after we are going to give to the quantum layer. Here the quantum layer which will perform quantum encoding, parametric circuit, and enjoyment element. After that, we are going to optimize the futures after quantum layer. Then we are going to apply the future optimization, future optimization. Then the classification output will be classified with five categories. Sorry, four categories. One is called the normal, AFID, PVC, and others. So this is the proposed methodology. And here we are going to present each and every step EC signals. So here multi-lead EC signals are taken. Lead one, lead two, lead five is taken, and they are going to use for a cardiac activity with the different perspectives. Here we are going to use the four classes: normal, superventricular, ventricular, and others. So here a balanced set of 40,000 ECG beats are created by selecting 10,000 samples for each class. So, ensuring the unbiased modeling, training, and evaluation. The data set is divided into training for 70%, that is 28,000 samples for training. Validation 15%, that is 6,000 samples. Testing for the 15%, that is the 6,000 samples are used. This is about the data set, so which will be publicly available on the web. When coming to the EC signal processing, here we have pre-processed signals. So for this, we used the Butterworth band pass filter here. So whatever the noise is there, or if any duplication and repeated features are there, so that will be eliminated. So here, the filtered signals are again normalized to zero, mean, and unit variance. So here we used some fun Tompkins algorithm. So it detects R peaks and segments E signals into the fixed length heartbeat windows. So this is about the ECG signal pre-processing. Then 1D CNN, so which is going to be used for spatial features. Is going to extract the spatial features. So once the raw ECG heartbeat segments are given to the 1D CNN, so that automatically extract the local morphological features. So here the CNN lens, so the descriptive patterns from the key ECG components, so including the P wave, QRS, complex, SP segment, and the T wave. So these are will be represented generally in ECG signal. So then we used the stacked convolution and activation layers progressively to capture the hierarchical spatial representation. Again, the extracted high-level feature representation is forward to the next layer, that is called the transformer encoder for modeling the long-range temporal dependencies. Here, the high-level spatial features extracted in one day, they are given to the transformer. The transformer employs a self-attention mechanism. So, to identify and emphasize the most informative time steps within the AC sequence, by learning global temporal relationships, so the transformer effectively captures the heartbeat rhythm variations associated with the different arrhythmia types. So if any problem is there in a rhythm, so that will be identified and that will be classified into category, that is a category one or two or three or four like that. So here the combined spatial and temporal representations provide a comprehensive feature set, and that set is subsequent to the variational quantum circuit, which is going to be used to perform enhanced future learning purpose. We use this transformer variational quantum circuit. Here, so whatever the spatial and temporal features are extracted from the transformer, so they are projected to a lower dimensional future space to enable the efficient quantum processing. So a future projection layer bridges the classical deep learning backbone and the quantum computing module. So here, whatever we extract the features, they are converted and they are so suitable to the quantum computing. So the projected features are scaled and encoded into a quantum compatible representation, so making them suitable for processing by the variational quantum circuitry. This transformer preserves the most discriminative arithmetic-related information while reducing the dimensionality, enabling effective quantum enhanced future learning. So next step is the quantum layer. And this quantum layer, which is a combination of the three layers, already we have seen
Excuse
in
me.
proposed methodology.
I'm so sorry to
Yes.
interrupt. You have less than a minute left.
Okay, madam. Okay, madam. I'm going to conclude this one. This is the quantum layer, and this quantum layer going to be used for the superposition and it uses superposition and environment that reduces less the complex nonlinear relationships so that are difficult for classical models to capture. So the enhanced quantum feature representing improve the collapse observability. This is the future optimization, and for the future optimization, we use squeeze and excitation function. So with the help of this tool, we are optimizing the futures, so which are generated from the quantum layer. Right? So this is the classification output. This is the final stage of our proposed method here. So we use the softmax activation function for the multi-class classification. Here, once the arithmetic is written, then we are going to classify whether it is an output is detected, then we are going to classify whether it is a normal superventricular or ventricular others. So this is the class with the highest softmax probability is selected in the final clinical. So this is the resultant analysis. Here we compared the existing method models with the proposed model. So coming to the existing model, here it's machine learning and the deep learning models. And among deep learning, again, we consider the hybrid models. Coming to the first, the SVM, the accuracy is 79%, the CNN 85%. Coming to the hybrid models, CNN and LSTM 88%, and the CNN plus transformer 91%. So coming to our proposed quantum model, so here, so which achieved 92.8% in accuracy and 91.6 as a precision and 92.1% as a recall and so on. So this is the results, whatever here are the represented the table results and which are presented as a for here. So here all the matrices are represented SVM, CNN, LSTM plus LSTM, CNN plus transformer and the proposed method, right? Among all the methods and the proposed one achieved so better results than the existing one. So coming to this is the conclusion part here. So the quantum enhanced spatiotemporal deep learning framework was proposed by us. So which integrates the different techniques. The model achieved a superior performance than the existing with the help of the MITBH. The performance improvement is attributed to the combination of the CNN-based spatial future instruction transformer-based and the quantum enhanced nonlinear future representation. The limitation of this work is simulated quantum circuits on a single ECG data, so which may limit real-world generalization. The future work is we are going to use the real quantum hardware and which is going to be integrated with the explainable AI, clinical integrity. And when you did on a large, basically center ECG data sets. This is our future work. Where we have started this work also. So that's why we have just given this one as a small model. Then we so these are some of the references we have added. So this is about my paper presentation. So thank you so much for this. Hello. Hello.
Yes, Dr. Singh, if you have any questions, you may ask now.
No, ma'am. No.
Okay, sir. Thank you, sir. Thank you so much.
All right, thank you.
Yeah, thank you. Shall I leave?
We will now, yeah, you can stop sharing. Thank you. We will now circle back to the first presenter who will be presenting a comparative study of single LLM and mixture of agent approaches in model context protocol based tool using systems. Janam, you may now begin your presentation.
Yeah, sure. Can you please allow me to share my screen?
You do have the permission.
Yeah, sure. Thank you. Uh, Good morning, respected professor, judges, and my fellow classmates. Myself, Jainam Shah, and today I am going to present a research paper, a comparative study of single LLM and mixture of agents approaches in model context protocol-based tool. This work has been carried out under the guidance of Professor Sindhu Nair and is a collaborative research effort by our team. Before I begin explaining my work, today LLMs such as ChatGPT, Gemini, Claude, and Llama have transformed the field of AI. Earlier, AI systems were mainly capable of answering questions or generating text. However, modern AI systems are expected to do more, much more. They are now expected to browse websites, access files, interact with database, call APIs, perform calculations and all. To perform such complex real-world tasks, AI needs to interact with external software and tools. This has given to rise to AI agents, which combine reasoning with action. Research focuses on comparing two different approaches using to build these intelligent agents. The first approach uses a single LLM to perform all the reasoning and decision making, whereas the second approach uses multiple agents working together collaboratively. Through this research, we aim to understand which architecture performs better. Let's move to the introduction. AI has evolved tremendously over the last few decades. Initially, AI systems were based on fixed rules. Developers had to manually specify every possible condition, and the system simply followed those predefined instructions. These systems work well for predictable problems, but they completely fail whenever the environment change or unexpected situations occur. Later, ML introduced a new paradigm where systems learn patterns directly from data instead of relying entirely on manually written rules. Deep learning further enhanced AI capabilities and all. Today, we are witnessing another major revolution with the emergence of LLMs, commonly known as LLMs. Models like GPT-4, Claude, Gemini, Nano Banana are trained on enormous amounts of textual information collected from websites, books, research papers, and all. However, modern AI applications require much more than simply generating text. Imagine, please book my flight from tomorrow, check the weather at my destination, download the boarding pass, save it to my Google Drive, and send me a reminder on calendar. Answering this question, the AI first needs to understand my intent, then it has to decide which website to visit, which services should be used for the Google Calendar, and also need to call the weather API. Finally, it has to perform every step in the correct order, which remembering what has already been completed. Unlike traditional chatbots, AI agents do not simply generate text. They can actually perform actions by interacting with external tools and software. This combination of reasoning, planning, and memory and action execution is what make modern AI agents extremely powerful. Let's come to the problem statement. Now let us clearly understand the problem statement. Currently, AI agent systems are becoming increasingly popular across many industries, such as healthcare, finance, software engineering, cybersec, etc. This dependency on one model creates several weaknesses. As task complexity increases, the model becomes more prone to reasoning errors, hallucinate more, incorrect tool selection, and reduced robustness. This limitation becomes even more significant even the task involves multiple tools, several sequential decisions, or long contextual conversations. Does collaborative reasoning among multiple AI agents actually improve overall performance? The answer is no. To answer this question, our research paper compares both architecture from single LLM and a comparative mixture of agents using MCP bench framework. The MCP bench framework compares focuses on four major performance such as task success rate, tool selection accuracy, execution latency, and response consistency. Our goal is not to identify which architecture performs better, but also to understand the trade-off between computational efficiency and reasoning robustness. Let's come to the literature review. Before developing any research project, it is important to understand what work has already been done by other researchers. This helps us identify existing solutions, understand their strengths and weakness. During our literature survey, we studied several research papers related to LLMs, AI agents, multi-agents, and MCP. One of the first important was that React one, uh, which was which was done by mainly generated answers direct React. This significantly improved the decision-making capability of AI agents because instead of immediately answering, the model first analyzes the situation and then selects appropriate actions. Like this, we have studied around 8 to 10 research papers and all. Apart from these, let's come to the research gap. After reviewing all these research papers, we identified an important gap in existing research. Most existing studies focus only on single LLM. Some papers evaluate single LLMs while others propose multi-agents. However, few studies compare both architecture under exact the same experimental conditions. Another issue is that many evaluations are performed using custom dataset or small experimental environment. Because every researcher uses different data set, different tools, and different evaluation metrics, it becomes difficult to compare the results. For example, multi-agent systems generally produce better answers, but they also consume more computational resources, require more communication among agents, and increasing execution time. Existing research does not clearly identify the situation where there is additional complexity is actually justified. Therefore, our research attempts to bridge the gap between the single LLM and mixture of agents using the same benchmark, the same task, the same tool, and the same evaluation metrics. Therefore, we have tested both in the same environment. This enables a fair comparison and provides a better understanding of each and every architecture. The score, let's come to the score. Let's first understand objectives and the scope. The primary objective of our research is to compare two different AI agents. However, a comparison is not limited to simply checking which one gives more correct answers. Instead, we evaluate multiple aspects. First one is the task success rate, which tell us how many tasks each architecture completes successfully in a given time frame. The second is the tool selection accuracy. Since AI agent interact with multiple in external tools, selecting the correct tool is extremely important for a successful execution. Third is the execution latency. While multi-agent systems may improve reasoning, they also involve communication among multi-agents. Therefore, we wanted to understand how much additional time is required. The fourth is the last but not the least, consistency. If we execute the same task multiple times, does the system consistently produce eligible outputs? Finally, our overall objective is to understand the trade-off between computational efficiency. And in our research paper too, we have showed the graph below of the four selected parameters. Uh, This is our four parameters. In this, we clearly see single LLM has efficiency equal to the mixture of agents. But while comparing to the consistency, tool selection accuracy, and task success rate, mixture of agents is much more better than the single LLM. Now comes to what is model context protocol. To understand MCP, let us first think about how AI models communicate with external software. Suppose ChatGPT wants to access your Google Drive. They drive a locally file manager. Each of these tools has completely different interface. Developers traditionally had to write separate integrations for every tool. This increased complexity and made AI systems difficult to maintain. Different devices such as keyboards, printers, hard disks, and cameras all use the same USB. Similarly, MCP act as a universal interface between AI models and external tools. This standardization communication significantly improves the scalability of AI agent to interact with the external software. Now comes the MCP bench. MCP bench was specifically designed to evaluate AI agents that use external tools through the model context protocol. So MCP bench is just a framework which help us to evaluate to test the comparison between the single LLM and a mixture of agents.
Excuse
Now
me, I'm
talking
so
about the
sorry to interrupt. You have 1 minute left.
okay. Um, now talking about the system architecture. This task is the MCP which act as a standardization communication layer between the AI models and external tools. The They use the single LLM input and react with the backend and automate the browser automation and goes to the monitor logging. From that, it will use the REST API to interact with the database and query out the output and give to the user. This overall measures the percentage of tasks were completed successfully from start to end. Uh, yes, the experimental results. Yes, the implementation details. Yeah, just a second. Although our research paper demonstrates the advantages of collaborative AI agents, there are still many opportunities for future improvements. One promising direction is the development of hybrid AI architectures. Instead of always using either a single or multiple agents, future systems could intelligently decide which architecture should be used depending on the task this dependency. Yeah. The real applications are in the healthcare, in software engineering. AI agents can independently generate code, review security vulnerabilities in finance and in cybersecurity. Yeah, thank you.
Dr. Singh, do you have any questions?
Oh, Jana, I have only one suggestion. Kindly
Yes,
make the PPT in a tabular format.
yes, sir.
Please take care in future presentations. Rest is okay. Thank you.
Yes, sir. Will note it. Thank you.
Thank you. We'll now move on to our next presentation. Our next presenter for today is Gayatri, who will be presenting Attention Enhanced LSTM GRU model for sentiment analysis of Dravidian code mixed text. You may now begin your presentation.
Good morning, everyone. Today I'm going to present our paper titled Attention Enhanced Listening GRE Model for Sentiment Analysis of Dravidian Code Mixed Text. Nowadays, people frequently share their opinions on social media platforms like Instagram, Twitter, Facebook, and YouTube. So instead of using only one language, they often mix English with their native languages in the same sentence.
Excuse me, Gayatri. I'm sorry to
Yes.
interrupt. Please share your screen.
Okay.
Please unmute.
So sorry, ma'am. So sorry, ma'am. So the sentence, yeah, this movie was awesome, but ending thodi boring thing contains both Hindi and English. Human can understand its meaning, but for computer it gets difficult because of language mixing, spelling variation, slangs, and informal writing styles. So our goal is to accurately classify the sentiment of such code mixed language as positive, negative, neutral, or mixed. So existing sentiment analysis model perform well on text written in a single language, but they struggle with multilingual code mixed text. Even deep learning model do not understand the meaning better. So to address this problem, we propose an attention enhanced LSTM GRE model, where the focus will be more on sentiment bearing words. Now talking about the literature review. So before designing our model, we studied previous research in sentiment analysis. The field has evolved from traditional lexicon based and machine learning approaches like logistic regression, decision tree, random forest to deep learning models such as CNN, RNN, LSTM, and GRE. More recently, transformer-based models like BERTs have achieved state-of-the-art performance. However, code mix text is still challenging because of transliteration, sarcasm, and irony found in the code mix text. Now for our experiments, we have used Dravidian code mix sentiment analysis dataset, which contains real social media comments in Tamil, English, Kannada, English, and Malayalam English. So since the data set was imbalanced, we used a stratified train test technique to preserve the class distribution. The pre-processing steps included removing URLs and special characters, converting text to lowercase, tokenization, and etc. Talking about the proposed methodology. So first, the input sentence is tokenized and each word is converted into a dense vector using an embedding layer. The embeddings are passed to the LSTM layer, which captures long-term contextual information. The output of the LSTM is then passed to the GRU layer, which efficiently captures short-term dependencies while reducing computational complexity. The key distribution of our work is the attention mechanism. So instead of treating every word equally, the attention layer assigns higher importance to words that carry stronger sentiment. For example, in the sentence, the movie was absolutely fantastic, the model will focus more on the word fantastic rather than focusing on other words. So the weighted representation, which is also called the context vector, is then passed through a dense layer, and finally a softmax classifier predicts whether the sentiment is positive, negative, or neutral. Now talking about the result, to evaluate our model, we compared it with several baseline models, including logistic regression, decision tree, random forest, CNN plus GRU, and LSTM plus GRU. Among these, LSTM plus GRU achieved the best baseline performance. After adding the attention mechanism, the performance improved further. Like the macro F1 scores increased as for Tamil, it increased from 0.58 to 6.61. For Kannada, it improved from 0.44 to 0.48. And for Malayalam, it showed the highest improvement from 0.56 to 0.65. So these results show that the attention mechanism helps the model focus on the most important sentiment-bearing words, leading to better prediction accuracy. Now talking about the future scope. In the future, we focus to extend our work to transformer models and we use larger data sets. So to conclude, we propose an attention-enhanced LSTM GRU model for sentiment analysis of Dravidian code mix text. By combining LSTM, GRU, and the attention mechanism, our model captures both long-term and short-term contextual information while focusing on the most important words in a sentence. The experimental results demonstrates that our proposed model outperforms the baseline model and improves sentiment classification performance. Thank you.
Dr. Singh, do you have any questions?
Yes, as you shown in the PPT, you
Yes,
have
sir.
tested your
Sorry.
model on 3 languages only.
Can you please repeat your question, sir?
As you have shown in your PPT, you have tested your model on 3 languages only.
Yes, sir. Actually, the dataset contained only 3 languages, that is Tamil, Malayalam, and Kannada.
Okay, where did you get this data set? Is
Sir,
it paid or a free data set?
no, sir, it was available.
It is available on which website?
Sir, on Google Scholar.
Only Google Scholar. Okay. Okay. Try to implement this model on a heavy and large data set. It's my
Yes,
suggestion. Try this model on various language data set and a large data set.
yes, sir.
Thank you.
Okay, thank you for suggestion, sir.
Thank you. Our next presenter for today is Pulkit Gupta, who will be presenting CryptoShield, browser-based anomaly detection using runtime telemetry. You may now begin your presentation.
Hello, am I audible?
Yes, you will.
Yeah, just sharing my. Is it visible?
Just one moment. Yes, it is.
Yeah, so good morning, everyone. I am Pulkit Gupta. I'm here with my project on CryptoShield, a browser-based anomaly detection using runtime telemetry. So, in this, the modern browsers execute complex time-side code, but creating a new security risk like cryptojacking. So cryptojacking refers to where attackers use your data or your resources to mine cryptos, so as to solve complex puzzles on the crypto and to gain their access over the cryptos that they have mined using your resources. So most of the browsers uh, they use normal antivirus softwares, but they cannot see this because this cryptojacking works only on a specific tab. And when you close that tab, you cannot, what you can say, track it down. So in this way, hackers can use your resources for mining cryptocurrency. So this is, so that's what I said. There's a vulnerability when your resources are exploited by the hackers. So when you open a different website, it might redirect you to some different, or it might start reloading on its own. So there are different, what you would say, reloads on a single page, which you don't even know of happening in the background. That's where the crypto jacking comes into place. So this was a problem statement. There was no signature-based limitation like URLs blacklisting or struggles to novel adaptive attacks. High consumption can be a legitimate, but making threshold-based detection prone to false positive. And the goal was to make visit websites that are not malicious but consuming high easier. So we actually went through different research papers, but what we found the gap in it was everyone was training their models based on the data that was previously or on the network or on the host based data. So they were tracing out network packages. So that network packages can be through any of the tabs, or we can be on the background as well of your other applications, not just your Chrome browser that you're using at the currently. So we found that gap and we worked on out. So we'll get you to the lit. So getting out to the proposed architecture. So what we are thinking is we have a browser extension cloud function. So we will have a ML model running out on the cloud function. And as we open a website, so it sees through your what you can say DOM files and the matrices that a Chromium browser gives out. So we will extract that and we will use a API to predict the response of how or what changes are being made. And based on that, our ML model will give out a prediction that it is anomalous or not. So we are using our data set that was not used, like we have created our own data set. So we created a Cloud Run function in which we ourselves added an extension and we scraped out, or we can say just browsed out different websites at a different levels. So using LinkedIn or using ChatGPT at a various types at various times for various durations. And this gives us a new data set that was never used. So this is a model training part and getting back to the ML part. So we used different models like XGBoost, Random Forest, SVM, Logistic, but we got our major, what do you say, the major attention and MLP model. So we used a hybrid model with the deep learning model and the exhibition. So that was our attention MLP multi-layer perceptron model, and it gave us the highest accuracy that we have expected out of all the things. So this is the zoomed ROC curve and the attention MLP training curve. And these are the different matrices that we used while training our data or our model. So event loop, like how many events were running in behind in the background, the ideal ratio, or how many for how many seconds or how many minutes a browser or a tab is idle. So network per second, how many network requests were sent, the DOM API or the DOM mutation. So on what or how many times the background or the event loops has started, post request, how many times the page has sent a post request to a server. So we can see all of that over it, and we have predicted our model on that. So this is just a model comparison on what the accuracy was, what the precision was, what the recall was. So as you can see, attention MLP, what our major ML model has, it has a 0.99 accuracy with the precision of 1 and a recall of 0.9. So this is the UI design that we were like presenting out, though we have made it an application and we have run out the ML model for it. That's the unique contribution from my side. And that's the references. Thank you. Or any questions? Hello.
Dr. Singh, do you have any questions?
No.
All right.
Thank
Thank you.
you.
We'll move on to the next presentation now. Just one moment. Our next presenter for today is Ayushi Bisht, who will be presenting Generative AI-driven investment sentiment modeling, a predictive and prescriptive analytics approach for financial decision intelligence. You may now begin.
Is my screen visible?
Yes, it is.
Is it visible now, ma'am?
Yes, it is.
Good morning, everyone present here. Today, the topic of my presentation is Generative AI-driven investment sentiment modeling, a predictive and prescriptive analytics approach for financial decision intelligence. I am a research scholar from Graphic Era University. This is my topic, and this topic mainly explores how generative AI can analyze investor sentiment, predict future market trends, and recommend optimal investment strategies to improve financial decision making. So let's start with its introduction. Basically, investment sentiment plays a crucial role in influencing financial market and investment decisions. Traditional models mainly rely on historical price and financial data, but they often fail to capture investors' emotion and reactions to market events. Generative AI overcomes this limitation by analyzing diverse data sources such as news, social media, and financial reports to understand investor sentiment. This enables both predictive analytics and prescriptive analytics. Predictive analytics, which forecasts market trends, and prescriptive analytics, which recommends optimal investment actions. As a result, generative AI supports more informed, accurate, and intelligent financial decision making. Next slide. This slide compares traditional finance with behavioral finance. On the left hand side, there is traditional finance, which assumes that investors are completely rational. They make decisions based on facts, financial data, and logical analysis. And on the right hand side, there is behavioral finance that recognizes investors are not always rational. Their decisions are influenced by emotions, psychology, fear, greed, overconfidence, and market news. So I have done almost around 20 literature reviews, and this is the crux of that literature review, which shows that generative AI can improve investment decision making in many ways. It provides accurate market insights, processes larger amounts of financial data quickly, adapts to real-time market changes, and gives transparent recommendations. It also helps reduce emotional biases and increases investors' confidence. Based on these findings, this study proposes 6 hypotheses to examine how these AI capabilities influence investment decision intelligence. So here is the research objective. The objective of this research is to explore the influence of these 6 AI capabilities on investment decision intelligence. These 6 capabilities are AI-generated market insight quality, information processing efficiency, real-time data adaptability of generative AI, explainability and transparency of AI outputs, perceived predictive capability of AI, and behavioral bias reduction through AI assistance. The main objective of this research is to examine how different capabilities of generative AI influence investment decision intelligence. Overall, this research aims to determine how these AI capabilities improve investment decision intelligence and support better financial decision making. So this is the research methodology. The study is quantitative in nature and it focuses on numerical data and statistical analysis. This is based on primary data, which has been collected from various retail and institutional investors. The sampling technique here used is convenience sampling. The questionnaire is prepared here and circulated among 240 investors, out of which only 150 respondents have filled the questionnaire, and only 130 responses are analyzed using PLS-SEM because few respondents have not filled the questionnaire completely. These responses are collected based on Likert scale. So here is the data analysis. This is the PLS model, and on the left-hand side, there are 6 different independent variables, and on right-hand side there is one dependent variable. The numbers on the arrows connecting the constructs are path coefficients, which shows directions and strength of the relationship between each AI capability and investment decision intelligence. On the left hand side, there are 6 independent variables, and on the right hand side there is one dependent variable. In a circle, orange circle, it is showing R square value, which is 0.428, which means the proposed AI related factor explains 42.8% of investment decision intelligence and indicating a moderate explanatory power. Because R square around 0.40 is generally considered acceptable because human decision making is influenced by many factors and not only by generative AI. So the next slide shows p-value. P-value means it determines the statistical significance of the relationship between independent and dependent variable. Here, the p-value is less than 0.05, which indicates that the relationship is statistically significant and the hypothesis is supported. Actually, the p-value is never exactly 0, but smart PLS rounds very small values, which is less than 0.01 and displays them as 0.000. It means these values must be less than 0.001. The next slide is showing average variance extracted. The threshold limit for average variance is 0.50 or above, which explains more than half of the variance in its indicators. And almost all these values are above 0.50. The next slide is showing heterotrait monotrait ratio, means HTMP ratio. It is used to evaluate the discriminant validity. It means it checks whether the construct in the model are distinct from each other and measure different concepts. Since all values are below 0.85, the model demonstrates good discriminant validity. So here is the conclusion. The above study shows how generative AI tools help investors by recommending the securities for investment by systematically analyzing various factors which affects the investor's decision quality and their sentiments. The integration of predictive analysis allows investors to anticipate future market trends, risk, and price movements, while prescriptive analysis helps in identifying new suitable investment options. The value of R square, as I earlier discussed, indicating 42.8% of the variance in investment decision intelligence is explained by the model. This reflects moderate explanatory power, which is acceptable for behavioral and decision science approach. Thus, the study suggests that as financial markets continue to grow, generative AI based sentiment modeling is likely to play a crucial role in shaping the future of intelligent and data-driven investment decision making. Here are some features of this study, as I have taken data from the respondents only once. So the future studies can include a larger number of investors from different age groups, income levels, and countries to improve generalizability. And instead of one-time data collection, future research can track investor sentiment over time to study changing behaviors across market cycles. And the last one is future models can use live data from stock exchanges, news portals, social media, and economic reports for real-time sentiment prediction. Thank you. Any question?
Dr.
Hello.
Singh, do you have any questions? All right. In case there's no questions, we'll move on to the next presentation. Thank you.
Okay, thank you.
Our next presenter for today is Adrinal Sandra, who will be presenting motivational drivers of user engagement in human-computer interaction and their impact on confirmation. You may now begin your presentation. Excuse me, Adrinal. I'm not sure if you're speaking, but you're inaudible.
Audible now? Am I audible now?
You could please speak up a little bit.
Am I audible now?
You're very faintly audible. I would recommend that you speak up.
Okay. Okay. Okay, so this is the presentation on motivational drivers of user engagement in human-computer interaction and their impact on confirmation. So before I start off with my presentation, I would just thank respected chair.
Excuse me, Adrinal, we can barely hear you. Please speak up.
Is it audible now?
No, Adrinal, you would have to adjust your microphone volume. If you're facing issues, we could circle back to you and move on to the next presentation.
Okay.
Oh, we can hear you now, actually.
Okay, here now?
Yes, we can.
Okay.
All
So,
right.
respected chair, distinguished researchers, academicians, scholars, and esteemed members of the audience, a very good morning. It's my privilege to present our research titled Motivational Drivers of User Engagement in Human-Computer Interaction and Their Impact on Confirmation. The first thing is, what is HCI? What is human-computer interaction? HCI has evolved far beyond the traditional understanding of humans, simply using computer as tools. Today, we are not just seeing computer as tools. Today, individuals interacting with digital systems through visual interfaces, voice assistants, intelligence applications, recommendation systems, and various forms of personalized technology. Consequently, understanding why users engage with such systems has become an important area of inquiry. Now, what's the gap now? Why we are doing this research? While existing research has extensively examined technology adoption, acceptance, satisfaction, but comparatively less attention is given the why factor is that understanding the underlying motivation that drive users to engage with technology in the first place. This observation motivated the present study. Now, when we are talking about this, based on this framework, we examined three major motivational dimensions. The which is known as the intrinsic motivation, then HCM stands for hedonic motivation, and the last one which we talk about is SOM, which stands for the social motivation. Utilitarian motivation, what's it? It's basically refers to the practical and functional benefits users often engage with technology because it helps them to accomplish some tasks, or you to get them with acquainted with certain skills. We talk about hedonic motivation. What is it? Hedonic reflects amusement, enjoyment, pleasure, all these things. Why they're using this technology? Is it for that particular purpose they're deriving from there? And the social motivation, which we talk about, is basically a desire for interaction, social connection, recognition, and participation with other communities. We further investigated how these motivations influence customer engagement in human computer systems and how such engagement subsequently contributes to customer confirmation. The confirmation is the fact that whether they are sure that whatever they have thought of, their expectations and their desired gratifications, what they have thought of before using the system, were those things fulfilled. So based on this theoretical framework, we proposed our hypothesis. So as you can see, that the hypothesis, utilitarian motivation positively influences customer engagement. That's the first one. And then you have the social motivations for the second, H2. The third one is for H3. All of our hypothesis is that they have a positive relationship between those type of motivations and customer engagement. H4, that's the fourth one, is that the customer engagement positively influences customer confirmation. The methodology part now, how we have a descriptive cross-sectional research design, 353 Indian respondents. The demographic features, as you can see over here, based on their age, qualification, and annual income. Now, this is what we have. Their demographic features, a 5-point Likert scale was used over here for that particular research study. The survey instrument, as you can see, it ranges from 5-point Likert scale from strongly disagree being 1 and strongly agree is 5. This is the measurement model reliability. We have checked the content validity, internal validity, and convergent and discriminant validity. As you can see over here, the composite reliability scores, the average variance extracted AV scores, the maximum shared variance, squared variance, MSV, and average squared variance. And if you look over here, then the results demonstrated satisfactory composite reliability values for all the constructs, which ensures a very strong internal consistency. Similarly, the average variance, if you see at extracted values, exceeded recommended threshold supporting convergent validity. This is the hypothesis. As you can see over there, the values which are shown over here, the p value and the results. And if you see over there, the hypothesis which we have found, all of them were accepted. The utilitarian motivation showed a significant positive effect. Hedonic motivation also have shown a positive and statistically significant effect. Social motivation, however, if you look over here, that has the strongest influence on customer engagement among all the 3 motivational factors which were the purpose of study. Additionally, if you look like over here, customer engagement was found to have positively influenced the customer confirmation, indicating that engaged users are more likely to feel that their expectations have been fulfilled and therefore more inclined towards continued usage. So this is what is all of them were supported. And as I said, that social motivation is the strongest one, which is having the strongest relationship. Now coming to the discussion and implications. If we talk about that, the implications, yes, we have theoretical and managerial implications for the study. From a theoretical perspective, if you talk about that, it contributes to the growing literature on human-computer interaction by extending the application of users and gratification theory. It highlights the various, the utilitarian, hedonic, and social motivations on explaining how they are engaging with whatever their engaging behavior with the system. Interestingly, from a managerial perspective, the findings can suggest that how designers, developers, and service providers may benefit from adopting a balanced approach that integrates functionality, enjoyable user experience, and to interact with others, and meaningful social features. To conclude the presentation, I can say that UTM, HEM, SM, all of these have constructively and positively impacted, which in turn had driven the customer confirmation, and out of which is the SOM, that is the social motivational factors, has shown a very stronger connection. Though at this juncture, I want to tell that there are future scopes being kept open for this particular study, because this study was conducted among 353. A larger number of respondents can be selected since it's an exploratory study. So based on these data, what we have collected, it result shows this. However, for a bigger data set, the result should be generalized and based on this sample only. And one more thing is that, which is very important, is that all these, if you look about, all this focuses on a positive aspect. But on the negative, there may be some negative outcomes as well, like digital dementia, that is the erosion of the cognitive abilities. So in a future scope, if the researchers want, they can try to balance both, that how the engagement can happen, the motivational factors can make them engaged, yet the digital dementia can be mitigated by utilizing the various interfaces. So thank you so much. Thank you for your patient here.
Dr. Singh, are there any questions?
No, ma'am.
All right. Thank you so much.
Thank you so much.
We'll now move on to the next presentation. Our next presenter for today is Soumya Kanti Dhara, who will be presenting Understanding Information Overload in ICT-Enabled E-Agriculture, a farmer-centric perspective with reference to behavioral reasoning theory. You may now begin your presentation.
Thank you, ma'am. Is the slide visible?
Yes, it is.
Thank you. Good morning, everyone. Myself, Soumya Dhara, Assistant Professor of the Department of MBA, Haldia Institute of Technology, is going to present Understanding Information Overload in ICT-Enabled E-Agriculture, a farmer-centric perspective in reference to behavioral reasoning theory.
Sorry for the interruption, Mr. Soumya, your voice is not clear.
Hello, now is it clear?
Yes.
Thank you, sir. ICT-enabled e-agriculture has transformed farming by providing farmers with timely access to production, weather, market and advisory information through mobile apps, digital portals and decision support systems, leading to better decision making, higher productivity and improved supply chain coordination. The rapid expansion of digital information has created information overload, where farmers receive more information than they can effectively process, resulting in confusion, cognitive burden, contradictory advice and less effective decision making. Excessive digital engagement can reduce the ability to evaluate and prioritize information, making it difficult for farmers to convert available information into actionable knowledge, particularly in developing regions with limited digital literacy and infrastructural constraints. Information overload is a behavioral as well as technological challenge influencing farmers' trust in ICT platform, technology usage patterns and long-term adoption and effectiveness of e-agriculture systems. In research gap, So although existing studies have primarily focused on the benefits of ICT-enabled e-agriculture in enhancing farmers' information accessibility, productivity and decision making, limited attention has been paid to the adverse effects of information overload on farmer-centric decision process. In particular, there is insufficient empirical evidence on how excessive and heterogeneous digital information influences farmers' cognitive evaluation, decision quality, and their subsequent acceptance and continued use of e-agriculture platforms. Addressing this gap, it is essential to better understand the behavioral mechanisms through which information overload sets technology adoption and to develop more effective farmer-centric ICT intervention. The contribution of the study can help future researchers to identify the causes of information overload in ICT-enabled e-agriculture, providing a theoretical lens in designing a more sophisticated digital platform to optimize information traffic. The above may reduce farmers' cognitive dissonance in extracting pertinent information from the e-agriculture platforms, thereby improving farming decisions. Now, from the review of literature, previous studies on ICT adoption in e-agriculture have mainly examined its determinants and barriers. This study applies BRT, that is behavioral reasoning theory, to explain farmers' intention to use ICT-based e-agriculture under conditions of information overload. BRT suggests that the behavior is influenced not only by attitudes and social norms but also by context-specific reasons for and against adoption, which mediate between individuals' values, beliefs and behavioral intentions, offering deeper insight into ICT adoption decisions. The perceived benefits of farmer values. So we have chosen four constructs, that is farmer values and beliefs, which particularly for productivity, efficiency, risk reduction, cost savings and long-term sustainability, which has positive influence on farmers' willingness and intention to adopt ICT-based e-agricultural technologies. Reason for using e-agriculture, that is RFEs, such as timely access to information, better decision making, expert guidance and improved crop planning, provide strong behavioral justifications that positively motivate farmers' adoption of ICT-based agricultural technologies. Conflicting and irrelevant information and cognitive fatigue attributed to reasons against using e-agriculture driven by information overload discourage farmers from adopting or continuing to use ICT-based agricultural platforms by reducing trust, decision quality and perceived usefulness. Farmers' intention to use e-agriculture is determined by whether the perceived benefits of ICT-based agriculture outweigh the barriers, that is information overload, thereby influencing their willingness to adopt, continue using and upgrade digital agricultural technologies. So this is the hypothesized research model where we have connected the four constructs, that is farmer values and beliefs, reason for using e-agriculture, reason against using e-agriculture, intention to use e-agriculture. So there are 5 hypotheses. H1, that is farmer values and beliefs for e-agriculture positively and significantly influence reason for using e-agriculture. H2, that is farmer values and beliefs for e-agriculture has direct positive and significant influence on intention of using e-agriculture. H3, that is farmer values and beliefs for e-agriculture positively and significantly influence reason against using e-agriculture. H4, that is reason for using e-agriculture positively and significantly influence intention of using e-agriculture. And finally H5, that is reason against e-agriculture negatively and significantly influence intention of using e-agriculture. So this is the 4 constructs, and we have for each construct there are 4 items to prepare the questionnaire. So now we come to the research methodology. using descriptive research design, an online cross-sectional survey was conducted from November 2025 to January 2026 involving respondents from rural part of India, especially from West Bengal. Sampling and data collection method involves convenience sampling to be used in the survey, and responses were recorded in a 5-point Likert scale using a close-ended structured questionnaire. The sample size was carried out across 385 respondents, out of which only 283 respondents have correctly filled out the questionnaire. Now this is the demographic composition of the sample on the basis of farm size, education and yearly income of the participants. Now we go into the measurement model, that is reliability and validity testing. The values of composite reliability, average value explained, and this indicates above the threshold value, and CR, that is composite reliability greater than average variance explained, proposes convergent validity. Moreover, average variance explained greater than maximum shared variance and average shared variance indicates discriminant validity. Now we are going into the structural model, that is hypothesis testing. The indices chi-square by degree of freedom, goodness of fit indices, norm-fit indices, Tucker-Lewis index, and comparative comparative fit indices and root mean square error approximation indicates all values within the threshold range, which proposes a good model fit. Now from the hypothesis we are going into the path analysis, where we have shown that the p-value for each of the hypotheses is supporting to accept the hypothesis H1, H2, H3 and H4 and H5. So from the we are going into the discussion. The study examined the impact of information overload in ICT enabled e-agriculture on farmers' intention to use e-agriculture, and all 5 proposed hypotheses were supported. Farmer values and beliefs positively influence the reason for using e-agriculture, indicating that favorable perceptions toward technology encourage acceptance and adoption. FVB, that is farmer values and beliefs, also have a direct positive effect on intention to use e-agriculture, while traditional beliefs and resistance to digital transformation may reduce adoption.
Excuse me, I'm so sorry to interrupt. You have less than a minute left.
Thank you, ma'am. FVB significantly influence their reason against using e-agriculture, showing that existing perceptions can also contribute to resistance toward technology adoption. Stronger reason for using e-agriculture positively enhance farmers' intention of use, as awareness of its benefits increases willingness to adopt digital agricultural practices. The reason against e-agriculture, largely driven by information overload, have significant negative effect on farmers' intention of using e-agriculture by creating distrust, uncertainty and reduced motivation. Now we come into the theoretical and managerial contribution of the study. The theoretical contribution enhances the farmers' comprehension of ICT enabled e-agriculture and the impact of information overloading that affects the behavioral intention of using e-agriculture. It provides the lens for future researchers for identifying the causes of information overloading in ICT enabled e-agriculture platforms and mechanism to minimize its impact. It may motivate farmers towards continued usage of e-agriculture, thereby reducing their mental effort and improving farmer decisions. Managerial contribution helps managers, expert advisors, IT developers with valuable insights for optimizing information flow in the e-agriculture platform, thereby increasing the farmer efficiency through continued use of ICT enabled e-agriculture platforms. The conclusion of the study investigates the impact of information overload and ICT enabled e-agriculture on farmer decision and intention to use e-agriculture platforms. The positive relationship was established among farmer values and beliefs reason for using e-agriculture, and intention to use e-agriculture, indicating that favorable perceptions encourage technology adoptions. Reason for using e-agriculture positively mediate, while reason against using e-agriculture negatively mediate the relationship between farmer values and beliefs and their intention to use e-agriculture. The study makes important theoretical and managerial contributions by explaining how information overload influences farmers' behavioral intention toward adopting e-agriculture platforms. The use of convenience sampling and the dynamic nature of farmers' values, beliefs, and demographics and technology adoption may limit the generalizability of the findings. Future research should be incorporate socio-economic and cultural factors and examine the role of trust and satisfaction in influencing farmers' intention to adopt e-agriculture. So these are the references. Thank you very much. Any question?
Dr. Singh, do you have any questions? All right. In case there's no questions, we can move on to the next presentation.
Can I stop sharing, ma'am?
You may stop sharing, yes.
Thank you.
All right. Our next presenter for today is Naveen Kumar Saraugi, who will be presenting Understanding User Experience Formation in Human-Computer Interaction System and Brand Attachment. You may now begin.
Yes, ma'am. Am I audible?
Yes, you are.
My screen is visible?
Yes, it is.
Okay, thank you. So my name is Naveen Kumar Saraugi, and I'm going to present a paper on Understanding User Experience Formation in Human-Computer Interaction System and Brand Attachment. Introduction. Human-computer interaction is the study which focuses on how individuals interact with computer and technology. HCI studies how people use technology, it observes user behavior, and it makes technology accessible. Brand attachment is considered to be the psychological and emotional connection that individual creates with brand. Brand attachment can be characterized as sense of affection, connection, and passion. There is a little research found that contributes regarding these two variables, which explains the relationship between the understanding of customer experience in human computer interaction and development of brand attachment. The study identifies the factors that influence customer experience in human computer interaction and how HCI is subsequently influence the brand attachment. This paper makes an important contribution in the field of marketing as well as HCI literature by suggesting cohesive structure that connects the development of customer experience in HCI system with brand attachment. Our first variable, that is behavioral change technique, is embedded within HCI system, play a crucial role in shaping the formation of user experience. Various techniques that actively guide user behavior in enhancing the quality of interaction are goal setting, prompts, feedback, self-monitoring. Customer experience in HCI is multidimensional construct covering user cognitive, emotions, and behavior reaction. That's why we take hypothesis as behavioral change technique has a positive correlation with customer experience. Next, prior studies are consistent in establishing the influence of performance expectancy on users' satisfaction and continued intention of using various digital platforms with mobile banking, e-shopping, and social networking applications. Performance expectancy has pivotal role in enriching overall experience. Therefore, we hypothesize as performance expectancy has positive correlation with customer experience. Again, prior research also depicts that price advantage is a critical factor in determining consumer evaluation has significant impact on users satisfaction, attitude, continued usage of technology enabled services. So price advantage acts as a important value driven stimulus that induce overall experience. So we take a hypothesis as price advantage has a positive correlation with customer experience. And now at the end, enriched customer experience acts as a key antecedent to the development of strong brand attachment. Enriching customer experience acts as a key attachment to the development of strong brand attachment. Therefore, we hypothesize as customer experience in human computer interaction has a positive correlation with brand attachment. This is our model. Here we can see that behavioral change the variables computer system. Now human computer system, now a customer experience in human computer system is influencing brand attachment. Methodology. Using descriptive research design, an online cross-sectional survey was conducted from January 2026 to March 2026 involving respondents from India. Our sample size is 391 respondents. From the convenience sampling, we surveyed and responses were recorded in a 5-point Likert scale using a close-ended structured questionnaire. This is the demographic profile of our respondents. There are two types of male and female, 206 male and 185 female. There are education background from to class 12, less than class 12 to PhD, annual income background from less than 5 lakh to more than 10 lakh. Now, measurement of model. In this slide, we can see that the composite reliability of all the variables are more than 0.7 and the average variance extracted is also more than 0.5, which shows that all the variables are significant. Now the hypothesis testing. So in the hypothesis testing, we have taken significance level 1%, and we can see that all the hypotheses are accepted with this significance level. The study result has confirmed that all the structure model fit indices are within the threshold limit. This confirms a good model. The regression coefficient and p-value of this study accepts all the hypotheses. The outcomes are indicative of the understanding that user engagement can be perfected using BCTs by directing behavior through organized method like feedback and goal setting, thus boosting both cognitive and emotional facet of the experience. Performance expectancy plays a pivotal role in customer experience by promoting how users opine about the usefulness and efficiency of the system, which in turn boosts user satisfaction and urges for continuing interactions. Price advantage, being a value-based factor, has an immense effect of assessing fairness and economic benefits of the users, further reinforcing their overall experience. Customer experience serves as a vital mediating factor in converting functional as well as value-based perceptions into emotional connections with the brand. In the implication, there are two types of implications we have. First, theoretical implication. The study aims to widen the HCI and marketing literature by using technology acceptance framework, particularly UTA UT2 in relation to customer experience and brand attachment, focusing behavioral and value constructs. From the managerial and financial perspectives, the findings guide the managers to make an attempt to design emotionally engaging user journey as positive experience gives furtherance to brand attachment, loyalty, and word of mouth. The study helps to construct a well-rounded connection of how users' experience is developed in HCI system and how brand attachment is affected by it. The present study has used convenience sampling, which limits the study within a specific geographic, cultural, and socio-economic region. Further, the research paves out a way to include more variables like perceived risk or trust factors and can espouse longitudinal methods to capture dynamic changes over time. Thank you.
Thank you, Nabeel.
Hello.
I believe the chair has been disconnected due to some technical issues. But in the meantime, we'll move on to the next presentation.
Okay, thank you.
All right. Our next presenter for today is Kavya V, who will be presenting voice-enabled autonomous AI shopping agent using NLP. You may now begin your presentation.
Yeah, thank you. Is my screen visible?
Yes, it is.
Yeah, good morning, everyone. I'm Kavya, and today I'm here to present our work titled Voice-Enabled Autonomous AI Shopping Agent using NLP. And coming to the flow of the presentation, we go through abstract, literature survey, problem statement, objectives and scope, existing system, system architecture, modules, results, conclusion, and then a thank you note. Coming for the introduction and the abstract, today e-commerce platforms provide millions of products, but searching for the right product is still largely manual. Users have to type the keywords, apply multiple filters, compare the products, and then navigate across several pages before making a purchase. So, as they rely heavily on the manual text-based navigation, making them less convenient for the hands-free users. Existing chatbots or voice assistants are limited to basic queries, lacking the ability to autonomously perform the shopping tasks. So this system is a voice-enabled autonomous AI shopping agent that uses NLP and speech recognition to process the natural voice commands. So existing shopping systems mainly rely on keyword-based search. They often fail to understand the actual intention behind the user's query and cannot maintain conversational context. So, a mock e-commerce platform is developed for safe testing since real platforms will restrict the bot integration. And coming to some of the objectives of our work, to enable natural voice-based interaction, to understand the user's intent using NLP, to maintain the conversational context, to support the autonomous task execution, and to provide a simulated e-commerce environment for the demonstration. And coming for the literature survey, before developing our proposed system, we reviewed several papers related to conversational AI, voice assistants, and intelligent e-commerce platform. So there were a set of papers that we could take. The first set of papers focused on AI voice assistants in conversational commerce, which was a large language and e-commerce shopping assistants. These studies show that voice interaction will improve the user's trust and provides a more natural way of shopping experience, and they emphasize the user experience and also the emotional aspects of it. The second group of papers, which was an artificial intelligence based chatbot with voice assistant, which was just a chatbot system with voice enabled interaction for improved user communication. There was a speech-based interaction, but it was limited for only a certain set of tasks, which was focusing on only basic chatbot functionalities. And these are some of the papers that we could take and identify some of the gap and the limitations of it. And we also reviewed research on multimodal AI agents and the workflow based conversational systems. These approaches demonstrated improvements in context handling and dialogue management, but most were evaluated in simulated environments and focused on text based interactions rather than the real time voice enabled shopping. So, based on these observations, we identified a research gap where existing systems either focused on user experience or supported only basic voice commands. They lacked an integrated solution capable of understanding the natural language, maintaining conversational context, and autonomously execute the multiple shopping tasks. So, our proposed VASA system addresses this gap by combining speech to text, RASA based natural language processing, dialogue management, backend automation, and a cloud database into a unified architecture. So coming to the problem statements. So the problem statement include how can we design a voice-enabled AI shopping agent that understands the natural language commands accurately, executes the multi-step shopping tasks such as product search, comparison, cart management, and simulated checkout, and operates autonomously within a safe, simulated e-commerce environment. So coming for the existing system and the architecture, existing work will include only a text-based chatbots which handles the FAQs or the simple queries, which is a customer service bots that we could find everywhere. And there are some of the voice assistants which will provide a very basic voice responses but lack the complex shopping task execution. Maybe they are mostly rule-based or limited intent recognition. There is no integration of multi-step shopping tasks. So we identified all these limitations and we were able to develop this particular work. And coming to the system architecture of our project, and the system will follows a multi-layered architecture designed for voice-enabled autonomous shopping. So we'll go through the flowchart of it. So firstly, the voice input where the users will begin by speaking a command. For example, the person can tell show me a Nike shoes under rupees some 3000 say. The user's speech will be captured using the web speech API and it performs the speech to text, converting that particular spoken audio into the text. At this stage, the system has only converted voice into text. It still does not understand the meaning of the sentence. And then comes the NLP processing layer, which consists of 4 different blocks, which is the intent recognition, entity extraction, context management, and the confidence check. Now the converted text will be passed to the RASA NLU where the natural language processing will take place. NLP is responsible for understanding the user's request where it will perform 2 major tasks. Intent classification and the entity extraction. Intent classification will identify what the user wants to do, whether it is to search the product, it is to add to cart, or is it to order, or is it something else. So depending on the user's request. Entity extraction is nothing but identifying the important information inside that sentence. Maybe it will be a brand, it will be a category, it will be a budget. These extracted entities are later used to query the database. In our project, RASA uses a DAT classifier, which is a transformer-based deep learning model capable of performing both intent classification and entity extraction simultaneously. And then comes the dialogue management, which is after NLP, the information will be passed to the RASA core. So where RASA core is responsible for managing that conversation after identifying the intents and as well as the entities, where it will remember the previous interactions for maintaining the context using the trackers and the slots. Slots are the memory variables that store the information such as product category, brand or budget. The tracker will store the entire conversation history. And then there will be a custom action server. After deciding the next action, RASA will call the Python-based custom action server. The action server will contain all the business logic. It communicates with the database, searches the products, filter the products, updates the cart, or process the orders, and performs all the backend operations that needs to be done. And then there will be a database, which is our product informations, which will be stored in the Supabase PostgreSQL. Supabase will provide a relational database support, REST APIs, authentication, and the scalability. And the action server will execute these SQL queries based on those extracted entities. The matching products will be retrieved and returned to our project. And then there is a response generation. The response will be sent back to the React frontend. The frontend will display the products. Finally, the text-to-speech module will convert that response into voice, allowing the assistant to reply naturally to the user. This completes the entire shopping interaction. So this is our entire system architecture that we have followed. And coming for the advantages of it, there is a hands-free interaction which will enhance the user accessibility and as well as the convenience. And there is a autonomous task execution which reduces the user effort in the online shopping. And there is a safe testing environment without relying on the restricted platforms, as those platforms will not allow the external bot integration. And there is a scalable design that can be extended with personalization, recommendations, and the future real world integration also. And there are some different modules that we have followed, which is a voice input module, which will capture the spoken commands via web-based microphone interface using web speech API. And there is a NLP and the intent recognition module, and as well as the entity extraction. Uses Rasa NLU to classify the user intent and extract the entities, maintains the context during the conversational turns to handle direct and indirect commands dynamically. There is a dialogue management and a response generation module which employs Rasa core and custom actions to manage dialogue flow, confirming user actions and maintaining conversational coherence. And there is a voice output module.
I'm so sorry to interrupt. You have 1 minute left.
Yeah, thank you. And there is a product search and the recommendation module, and there is a database integration and the user data management. And web interface and interaction module, which provides a responsive React based front end with voice and text input options, and action execution and automation module. And these are some of the results snapshots that we have taken. And coming for the results, so we before evaluating the model, we created a simulated e-commerce environment. We developed a product catalog containing 100 to 150 products from different categories, and the system was implemented using React, Python, Rasa, Supabase, and all. And we achieved intent classification accuracy of very high with the precision recall and F1 score also. And there was a confidence check that was also performed where most of the correct predictions fall in the high confidence range of 0.9 to 1. Incorrect predictions was occurring mainly in the 0.45 to 0.75 confidence range. And coming for the entities prediction confidence distribution also, the same report was shown. And we validated the model using Rasa's built-in testing framework, where we were actually make a comparison between the actual labels and as well as the predicted labels. And these are some of the results of it. And coming for the concluding part, the voice-enabled autonomous AI shopping agent effectively integrates speech recognition to enable natural voice-driven e-commerce, which improves accessibility for the users for seamless product search, cart management, and all. And coming for the future work, we can add multilingual support and incorporate emotion and sentiment analysis. We can introduce computer vision features for image search and all. And these are some of the references that have referred. And thank you.
Dr. Singh, do you have any questions? All right. In case there's no question, we'll now move towards the closing remarks.
Yeah, thank you.
So I would sincerely like to thank all of our authors for their excellent presentations and contributions in this session, and all our participants for being a part of this international conference. I hope this session was informative, and on behalf of the whole team, I thank you for your support during this 11th version and all the previous 10 versions of the conference. We will be happy to have you in the 12th version in 2027. All presenters will be receiving their digital certificates through email within the next 2 working days. The publication will be live in 7 to 8 months. Kindly cooperate with the team of ICT4SD 2026. I also like to thank our session chair for today. This is a token of appreciation to the chair on behalf of Team ICT4SD 2026 and Global Knowledge Research Foundation and partners. Thank you so much, Dr. Singh, for chairing the session and for your valuable presence. Before we conclude the session, I would like to request everyone to please turn on their cameras for a virtual snapshot. Thank you so much. The session is now adjourned.